Imagine a fortress buried deep beneath the earth, designed to withstand anything. A place where secrets are kept, where threats are harbored, seemingly beyond reach. For generations, military strategists have grappled with this ultimate challenge. How do you strike at the heart of an enemy when that heart is encased in layers of reinforced concrete and rock? It is a question that has haunted commanders since the first castle walls rose from the ground, evolving from siege engines to aerial bombardment, but always facing the same fundamental problem. How do you defeat what you cannot touch? For decades, the answer lay in brute force. Massive bombs, dropped from high altitudes, designed to smash through layers of hardened material. They were called bunker busters, and for a time, they represented the pinnacle of destructive power. But as technology advanced, so did the defenses. Adversaries began constructing facilities deeper, with more sophisticated reinforcement, often nestled within natural rock formations. These were not just simple bunkers anymore. They were subterranean cities, command centers, weapon storage sites, and even manufacturing plants, all designed to be impervious to conventional attack. The old methods, the legacy bunker busters, began to show their age. While effective against some targets, they often fell short against truly hardened, deeply buried facilities. They might create a crater or surface damage, but the critical infrastructure, the true heart of the target, remained intact, humming along, protected by hundreds of feet of earth and steel. This created a strategic dilemma: how to neutralize a threat that could not be reached, or deter an adversary whose vital assets seemed untouchable. A new kind of weapon was desperately needed, one that could redefine the very concept of penetration. The challenge was immense, a true test of engineering and physics. It was not just about making a bigger bomb, but a smarter one, capable of thinking, adapting, and overcoming. Engineers faced myriad hurdles, designing a weapon that could accelerate to incredible speeds, withstand immense impact forces, and continue through multiple layers of rock and concrete without disintegrating. It also needed to detonate precisely where and when needed, deep within the target, for maximum destructive effect. This pushed the boundaries of material science, leading to new alloys for extreme temperatures and pressures. Novel aerodynamic designs ensured stability at supersonic speeds, even after initial ground penetration. Revolutionary guidance systems maintained accuracy while burrowing through dense earth, navigating unseen obstacles. Fusing mechanisms had to be intelligent, sensing the precise moment to detonate at the intended depth, or even triggering multiple charges in sequence for complex underground structures. This became an engineering arms race, a silent battle in laboratories and testing grounds. Every defensive improvement spurred new penetrator innovations. The stakes were high, impacting technological superiority and geopolitical power. The minds behind this project worked in secrecy, driven by purpose, knowing their success could mean the difference between strategic advantage and dangerous vulnerability. They grappled with the physics of destruction and the immense moral weight of creating such devastating power. Every calculation, material choice, and design iteration carried the unspoken burden of its potential use. Out of this crucible of innovation, a new answer began to emerge: the Next Generation Penetrator, or NGP. It was not just an evolution, it was a revolution. The NGP is a marvel of modern engineering, a weapon designed to overcome the seemingly insurmountable challenge of deeply buried hardened targets. Its core capability lies in its multi-stage penetration system. Unlike older bombs that relied on a single massive impact, the NGP employs a sophisticated sequence of events. First, its hardened, aerodynamically optimized nose cone, crafted from exotic, ultra-dense alloys, allows it to achieve incredible velocities upon impact, literally blasting its way through the initial layers of earth and concrete. But that is just the beginning. As it penetrates, internal sensors constantly feed data back to an onboard computer, assessing the density and composition of the material it is encountering. This real-time feedback allows the NGP to adjust its trajectory and, crucially, to time its internal processes with pinpoint accuracy. The true innovation lies in its intelligent fusing system. Instead of a single explosive charge, the NGP can carry multiple, independently fused warheads, or a single, highly advanced charge designed for delayed detonation. Imagine it. The bomb burrows hundreds of feet underground through layers of reinforced concrete and rock. And only when it reaches the precise, pre-programmed depth directly beneath the target does its primary charge detonate. This is not about creating a surface crater. It is about delivering a seismic shockwave directly into the heart of the underground facility, collapsing structures, destroying equipment, and neutralizing personnel with unparalleled precision. The NGP's guidance system is equally groundbreaking. Utilizing advanced GPS and inertial navigation, coupled with internal sensors that can detect changes in subterranean density, it maintains its course with astonishing accuracy, ensuring that even after burrowing through hundreds of feet of earth, it hits its target with devastating effect. This level of precision means less collateral damage, focusing the destructive power exactly where it is needed, a critical consideration in modern conflict. The strategic impact of the NGP is profound. It fundamentally alters the calculus for any adversary relying on deeply buried facilities for protection. What was once considered an impenetrable sanctuary is now potentially vulnerable. This new capability changes the game, providing a powerful deterrent and forcing potential adversaries to reconsider the viability of their underground strongholds. It offers a precise tool for neutralizing previously unreachable threats, reducing the need for widespread, less discriminate attacks. But with such immense power comes equally immense responsibility. The NGP is a testament to human ingenuity, a triumph of engineering over seemingly impossible obstacles. It represents the cutting edge of military technology, a tool designed to address the most challenging threats of our time. Yet, its very existence forces us to confront the enduring cycle of conflict and the relentless pursuit of destructive power. It is a stark reminder that as long as there are threats hidden beneath the surface, humanity will continue to devise ways to reach them. The Next Generation Penetrator stands as a symbol of both our capacity for incredible innovation and the sobering reality of a world where the ultimate fortress is always just a design flaw away from being breached. It is a weapon born of necessity, forged in the crucible of strategic challenge, and destined to reshape the landscape of modern warfare, for better or for worse.